Buenas tardes. How is everybody? My 3 students, I can see the users from my side. The class is a small class, it's under 10 students, so I don't have to wait too long before I should start here. How's everybody? Did you get a chance to watch the videos? We're going to talk about them today. So I did share a lot of things with you yesterday. I shared the prontuario, revised prontuario, so if you have any questions about the syllabus, please let me know now or soon. I sent you, I prepared the Moodle page, and you have an opportunity to navigate what's there. I probably should put a calendar up there, shouldn't I? I should put a calendar. Although there's not much calendarizing to do because it's only a 3-week class. I'll think about it. I guess I have the evaluation with the dates in it, so that will have to suffice. So it's going to be 2 units each week. That's what we're going to cover. Very good. All right. So you should have the notes in front of you. And I'm going to begin at the beginning. And then we'll get into the review of the videos. All right. So this is Unit 1, known as Collecting Data, Designing Experiments, and Surveys in order to collect the data. Data is a plural, so I have to be careful about the use of the word data. All right, so we begin with a question. Why do we study statistics? What is the goal of statistics? And before we get there, I guess I have to ask you, what is a statistic? What is a statistic? Obviously, you can't recopy what I've stated in the notes, but well, anyway, in your own words, what is a statistic? Try and articulate. What is a statistic? Okay, information in numbers, that's interesting, yeah? Predecir el futuro basado en data. Okay, information in numbers we study. A process analyzing data. Okay, so some of you answered about the discipline of statistics. But what is a statistic, the noun? We begin here. With a population of interest, a variable of interest, a characteristic of interest. And a population are the actual characteristics that exist. So, for example, I could say GPA of MBA students in Puerto Rico. So I can just say that. The GPA of MBA students in Puerto Rico. So the population would be all of the GPAs of MBA students in Puerto Rico. And often this would not be an issue if I actually had all the GPAs of MBA students in Puerto Rico at my disposal. Likely a single person doesn't have that, or even an entity. Like maybe I'll have that, I could get that information for our campus. Maybe I could get that information for UPR island-wide campuses. Maybe I could get that information for just some, but maybe not all, right? GPA of MBA students in PR. Now you can talk about how I'm going to look at that. I'll say grads. GPA of MBA students in PR. I'll say graduates just to be more specific. So I want to know that figure. It's really important to have an idea of about, how many GPAs there are out there. In other words, how many students have graduated. And we like to identify the number of those by the capital letter N population size. So this is what we want. But there are obstacles to acquiring this information. So rather than try and get all the information, because that can be costly or even impossible, might not have access to that information, permission to access, instead we can figure out what would be an adequate sample size and how to get a sample as part of the whole, which we can use in order to estimate the GPA for MBA grads in Puerto Rico. So a sample could be, maybe it's not a great sample, but it's a part of the whole, would be just looking at students that have graduated from our campus. All right, so now the original question was, what is a statistic? Now that I've written things out like that, in the terminology that I've laid out, what is a statistic? Again, I like to start over here. This is our goal, right? To summarize or acquire a measure of the GPA of graduate and MBA graduates in Puerto Rico. So a possible parameter, what we call in a population, a parameter of interest. So I'm very specific about this word use. A parameter is a number representing a characteristic computed from the data in a population of values or measures. I'm just making this in my own words to capture the concept. So a parameter is a number computed from the data in a population of values or measures. So, for example, a parameter would be the average GPA of MBA graduates in Puerto Rico. What's on this page that I've presented here? What's another example of a parameter? What's another, just related to the problem I have, a number computed from the data in a population of values. I could calculate the average GPA of MBA graduates. What else could I calculate? What's another parameter? N, the population size, is also a parameter. I don't have to really compute it, but it's a number that I calculate, identify. That's also a parameter. Those are parameters. I could calculate so using that population as a measure of GPA. I could be interested in average. I could be interested in some other measure of GPA. What about and we're going to talk about this if you never heard this term, what about the standard deviation of GPAs? Or let's make it easier. Let's just say the maximum GPA, it'd be more interesting to say what's the minimum GPA of graduates. Because somebody could have perfect. That's not so interesting, right? The minimum GPA of graduates so you can take a screenshot of what I'm doing if you like, so you could sit back, you don't have to write, or you can write along. Sometimes it helps to listen and then write in your own, you'll copy along what I'm writing in your own penmanship. Okay, so all I've done is clarified something you already have a sense about. It's nothing dramatically new here except the use of this term in a very specific way. So a parameter is a number computed from the data in a population of values. And I give you some examples. So now, the ultimate question, what is a statistic? In relation to what I just said. Okay, which data and Yvette? So I'm trying to clarify which data. So a statistic is a number computed from the data in a sample of values. Intended to do what? To estimate what we call a population. It's kind of redundant, but I'll put it in brackets, parameter. Okay. So that's what a statistic is. It's the equivalent value but calculated for the sample, because you might not even have access to the population data. So instead you use a statistic. That's why statistics are popular, because we can compute them. We have all kinds of samples. They might not be good samples. They might not be representative samples, in other words. But we have a bunch of numbers that we can put together and calculate a statistic from them. We're going to talk about what's good data. Actually, you watched the video about what's good data collection to help you understand samples and representative samples. So for example, just to wrap this up, for example 1, it's the average GPA of, so I'll show you my fancy skills in my iPad. So I could copy that over. The average GPA of MBA graduates in, so I'm just going to change it from the population to the sample. And in proper English, say okay, so that would be a statistic, the average GPA of MBA graduates from UPR, and then for number 2, the statistics would be n, the sample size. Notice I use a small letter n. That's quite universal to use the symbol small n. In some computer software, it doesn't differentiate. It uses cap n, whatever the case. So you really need to know what you're doing to understand what you have in statistical output. And finally, so this would have been out of all Puerto Rico, but for the sample, I'll do the same lasso. That would be the minimum GPA of MBA graduates from UPR. Everything's clear? I had a teacher who used to say that. He said it in a assertive way. So everything is clear now? Okay. Questions? So the statistic is a representative of the parameter. That's what it is. So the goal of the discipline of statistics is to gain information from data about a variable for the purpose of alleviating uncertainty. In other words, better understanding what to expect. Statistics help us to make predictions about what's going to happen. And if we can make predictions, then we can prepare. We can prepare for worst case scenario. If something was to go badly, we can prepare. If something is to go well, we could prepare. Statistics helps us. It helps position us in the future, a future that we cannot see. The strength of statistics depends on our ability to deal with a number of underlying issues around samples and representative samples, so that the statistics that we calculate actually are good substitutes for parameters. Any questions? So statistics in a modern world, in the Western world, statistics are a large part of our lives. They tell us, right now we're hanging on reports of cases reported of COVID. Those are statistics. I mean, that's just a sample. We might have missed counting certain people who haven't either been tested or whose test results. So we might have missed people. And there's also the possibility that we have identified people who don't actually have COVID because of false positive tests. All these issues around counting or identifying a sample are a part of the challenges of statistics, the field of statistics. Okay, so enough of that. What kind of data can we expect to see? So I'm going to spend some time talking about data, even though that wasn't in the video. It's really important to talk about kinds of data. The type of variable that you're dealing with, because the type of variable you're dealing with will determine the kind of statistics that you compute and the degree to which statistics are going to be good representatives of parameters. So data can be collected on a variable. A variable, what is a variable? Any characteristic of a person or thing that can be expressed as a number is called a variable. And I present you 4 examples. And with these 4 examples, once again, you have an intuition for what I'm talking about. I'm just going to help tease apart the different types of variables by comparing them to each other, okay, and labeling them, giving you a taxonomy or a list of different kinds of variables. And I'm going to do that using these 4 examples. Here are 4 variables: favorite restaurant, number of passengers in a car, the temperature outside, and performance rank. All of those can be quantified or measured as a number, or reported as a number that's been measured. But the nature of the number is different, distinct. So I'm going to start with comparing favorite restaurant and performance rank. What is the difference between favorite restaurant and performance rank? How would you articulate the difference between those two? Okay, very good. Okay, good. So in your own words, you're explaining it. So let me give you, for people who still, it's vague what we're doing here, I'm just going to outline what I'm talking about. So let's conduct an exercise in collecting data. So I'm going to use Excel to record my data collection. And I'm going to put this at the top, and then I'm going to ask people, what is your favorite restaurant? And people, let's see, I'm going to have a column here for subject, or I'll just call it ID. So for the first person tells me Popeyes, his favorite restaurant. Okay, and then I ask the second person, and I'm not going to get into how good or bad the data gathering is. I'll just say that however I obtained the information, the second was, there's a restaurant here, I'll say Linguini. So these are restaurants in Puerto Rico. And then third person says Pimenton. Actually, I have not been to Linguini, but I've been to the other two. And then a fourth person says Morton's. Oh, I love Morton's. Okay, so I have that for my data collection so far. And then the fifth person also says Linguini's. So that's my data. And I'm going to use ... to say I collect more. And I ask you now, that's not a number. So how can I make that a number? Because the definition Okay, very good. So you guys read the notes, or you knew these concepts before. So in this, to recode, so I'm going to recode the data. What you have to do, this is a huge part of statistics, is coding or recoding data, organizing management, data management. And I'm trying to think if I should give you an exercise in that, but if you ever have done data analysis, this is the beginning, is to organize or manage your data. So let's say I decide to call Popeyes, I identify Popeyes with the number 1. So every time someone says Popeyes, I'm going to translate that, I'm going to recode that into a number. Ingredients will be seen as 2, pimentone as 3, Morton's as 4. So this person, number 5, said linguine, so I use 2. Okay, so this is the way I convert favorite restaurant into numbers. Now that you've seen me come up with the values, did I do anything special? Did I compute anything? Did I think about the favorite restaurant? No, I just translated each name into a number. So every time I see Popeyes, the next person says Popeyes is their favorite restaurant. Put a 1. I'm not going to get into why it's a favorite restaurant, nothing like that. I'm just coding. Okay, I'm not going to judge what people have said. I'm just going to be coding. Okay, so this is an example of nominal variable. First of all, we say that this data is categorical. Or in other words, qualitative. Means the same thing. That the number that I have assigned to it, the value, doesn't have, I haven't measured it. All I did was code or categorize Popeyes as 1. So whenever I see Popeyes, I put a 1. Now another researcher could have collected data as well in Puerto Rico, and they might have come up, because they asked different people, so these are my different columns in Excel. The first person ended up saying I really like Viejo Almacén, so let's say Viejo. I'm doing free advertising right now. Viejo Almacén. And then someone said, oh, Texas de Brazil. I haven't been to a lot of these restaurants in a while. So this, they numbered 1. And then someone says churches. You know, there are people. My husband likes churches. Okay, so then the numbering scheme looks different, but that's fine, because the number doesn't mean anything. It's just, well, what it means is those are the people that picked. That's identifying, categorizing for Viejo Almacén 1. So I can continue like that. So in that sense, the assignment of those values is subjective. There's no objective number, there's no objective measure of these numbers. I've just said Popeyes, I'm going to call 1. This other guy said he's going to use 1 for Viejo Almacén. If I want to put this data together, I have to use their legend for coding and recode to combine data sets. Okay? So it's subjective, and Not objectively measured like with a scale or a measuring stick. Two different people could come up with a different numbering scheme with justification. And also they could renumber so that you could combine two data sets. Okay, so this is categorical or qualitative data. And then what I say is further, categorical or qualitative data can also be identified as nominal, where the numbers are not related in a particular way, like they're not related to each other in a particular way. Like 1 and 2 and 3 and 4 are just the assigned categories, but otherwise these numbers are not meaningful. Calculating an average with those numbers is rather meaningless. That's in contrast to ordinal categorical variables. In ordinal categorical variables, the numbers are related. So 1 is either higher or lower than 2, and that's really an added bit of information. Nominal values confer the least information. Ordinal values give you a little bit more. So this depends. Let me read your comments. Okay. Right, okay. Although I am interested in the favorite restaurant and which one's more favorite than the other, after all is said and done, just the assignment of numbers doesn't necessarily mean anything other than what category the individual subject, what category their choice falls under. Okay, so that is what I've said about favorite restaurant. Favorite restaurant is a nominal variable. That's different from performance rank. So performance rank would be using interviews and self-evaluation of staff. So staff can make their own self-evaluation, and then management will review depending on the performance of the staff member on a number of different dimensions. They could look at their personal ability, they could look at their productivity, you could look at all those things together and put them together and then compare employee against employee and rank them. In that case, those values that we come up with are subjective because one manager could come up with a different ranking than another manager. Or the same manager on a different day could come up with a different ranking. In that sense, it's subjective, the way they combine those numbers or those that information to come up with a ranking. And further, so it's categorical data, but then it's also ordinal because I'm putting the numbers in order, or I'm putting the numbers, give me or confer an order that the person who had the number one performance rank did better. So in that sense, favorite restaurant is different from performance rank. Both are categorical or qualitative variables. Values in particular categories are given a particular number and assigned subjectively. However, for performance rank, the difference is it's ordinal. So that's what the difference is. They're both qualitative, but this one is nominal and this one is ordinal. Now, what is the difference between favorite restaurant? No, sorry. What's the difference between the number of passengers in a car I'll use a highlighter. And temperature? Okay, good. So the first thing to note is both of those are quantitative variables. They're both values that can be objectively measured. And those numbers can be ranked and averaged. And that makes sense. Okay, so number of passengers in a car, if I was to sit at an intersection and count the number of passengers in a car, or at a traffic stop, maybe, they could be counted, right? So I could count the number of passengers in a car, somebody else could count the number of passengers in the car, and we both come up with the same result because we're just counting. Temperature also can be objectively measured. I can use a barometer, something, a measuring tool, and I could use a measuring tool and somebody else could be measuring the temperature, and because of a standardized tool to measure temperature, we'd have the same result obviously in the same place at the same time. So in that sense, both of those are quantitative, but the difference is so quantitative, not categorical, and this one is quantitative, not categorical. But the first one, temperature can be measured. The better or more sophisticated, more expensive your measuring tool, you could get greater and greater precision. So you could say the temperature is 20, well, I'll say it in 80.5532 degrees, or 80.5 degrees as the temperature outside. But can you have fractions of a passenger in a car? No, you're going to have 1, 2, 3, 4, etc. passengers in a car, depending on the size of the vehicle. So in that sense, we need to distinguish between these two types of quantitative variables. Number of passengers in a car is called discrete variable because we can only use whole numbers. Temperature, however, is different. It's known as continuous variable because I can have portions of an integer measure. But in both cases, I can use, those numbers are ordinal, they mean something, and those numbers can be averaged or combined to represent them or summarize them. Okay, so that's that. That's my summary that most of you have read the notes already or have seen that in the past. And I give you some examples here of other variables that are quantitative, like dollar sales forecast of a new product, the age in years of individuals, that's discrete if I use years. And construction's costs can be continuous because I can use fractions of a dollar. So, yeah, decimal values. Some examples of categorical variables: political party affiliation is nominal. It would be like the favorite restaurant where I assign numbers, and the numbers don't necessarily mean anything other than the categories 1, 2, and 3. In Puerto Rico, there's the 3 long-standing parties. Ranking of athletes would be ordinal, however, because I would have, the top, the second, and third athletes, or I can rank all the athletes. You'll see that in sports events where they rank the performance of athletes. Favorite restaurant is nominal, we discussed that, and customer satisfaction levels is ordinal, right? One could be more satisfied than another. That adds extra information beyond what a nominal variable does. We call that ordinal. Okay, so then that's all straightforward. It all makes sense. I gave you this exercise to try, and I gave you some solutions. Sorry, here. So I'm going to ask you if you have any questions about that. All I've done is presented, there were just blanks in the notes, and I presented these different variables, and I ask you to identify what type of variable it is and be specific. If it's quantitative, is it continuous or discrete? If it's categorical, is it ordinal or nominal? And then I put a column here so that you can write down what the values might look like to help you clarify your response over here. So this helps me, if there's a discrepancy, I can look at how you're thinking about the variable, and if this was a test situation, I could give you credit. So in the test for this class, they are going to be online and automated, but I'm going to invite you, as I mentioned in the syllabus, to submit to me your written work if that helps you to, in situations where maybe a question wasn't so clear, it might help you, get extra points or half points. So you can work out problems on separate pages and then scan those and send those to me. So things like this, justifying your thinking, it's really important, because your interpretation might be unexpected by me, and I'd be willing to give you credit. So for instance, this one is always interesting. Score on a test. Score on a test. What kind of score? Are you scoring with percentages? Are you scoring with whole numbers? That's really important. Or another alternative, what if you're scoring with letters? So in this case, where I'm using percentages, this would be quantitative and continuous. But if you're using whole numbers, like 67 out of 80, or 67, not percentages, that would be quantitative and discrete. But if you are using letters, suddenly it would be, the score on the test would be categorical. So what you write in this column ends up quite important. Did you want a moment to look at that before I get into the quiz to test your understanding? So I'll give you, okay, we spent an hour, so let's take 5 minutes, have a look at that, and see if you understand the nature of these variables. I'm back. Yeah, so 67 over, but yeah, 67 over 80, if you divided it, would be continuous. But let's say, I'll give an example of a discrete one. Out of 80, your test score was like, example would be like 55, 80, 60, 67, etc. That's what I meant when I said that earlier. Okay. Okay, so I think you understand that, but now I'm going to test your understanding. I'll ask you to answer this quiz. So take some time to consider these questions on this quiz. There are 5 questions. And what I want you to do first is answer or respond to the quiz on your own. And then, so just respond, try and fill this in so you get a sense of the questions being asked or the variable and the possible values associated with that variable and possible responses. And then I want you to categorize the variables. Are they quantitative in the first one or categorical? And then if it's quantitative, is it discrete or continuous? If it's categorical, is it nominal or ordinal? So I should give you some time to look at that. If you've not read this, take some time to read it through and we will discuss it. Alexandra asked me, are these quizzes in the materials PDFs, the ones we have to complete in Moodle? No, these are, they're similar. So this is just an idea, gives you an idea. The idea of this quiz is to test you and give you feedback on your understanding of what we just discussed. It's also to give you an example of the type of questions I will ask on the tests and in the quizzes. So yeah, it's similar type question that you get in the quiz. The quizzes, some of the questions are more challenging than the homework. The homework exercises, so there's homework exercises, there's practice assignments, and then there are the quizzes online. But I also have old exams online. So you have lots of materials to review. So let me know when I can get started looking at this. So some of you are done. This quiz tends to catch students off guard, and you'll understand once I'm done reviewing it why that is. This is similar to if you've ever filled out a quiz online or answered a quiz. Or sorry, not a quiz. If you've answered a survey, this is like a survey you might have filled in online or answered in the past. And it's really important to see what kind of variable is being collected and then we'll talk about what issues that raises. Okay, so this one is not in Moodle, no. This is just in the notes in Papel. So the first variable. What faculty are you registered in? Either art, continuing education, human ecology, science, or some other. So I could have, to collect this data and to enter it into a data management software, I could use, number these in alphabetical order, right? So art is first, continuing education is second, third, fourth, fifth. So I can assign numbers. So that is a variable. Now, what kind of variable is it? So you have to think about the nature of the numbers. I could assign this one is 1, this one is 2, this one is 3, 4, 5. But the numbers otherwise, other than just categorizing the responses, the numbers are not related. Well, in this case, they're alphabetical, but that doesn't mean I can add and average those numbers and that they're meaningful. So this is a classic example of a categorical and nominal variable. All right, that was straightforward. So the next one we might have a little bit of a discussion because I ask the person to respond to the question, on average, how many glasses of milk do you consume in a week? So the answer could be, like for me, it's about maybe 2 glasses. I don't even say 2 cups, but okay, so 2 glasses, you know, or maybe if I feel somewhere in between 2 and 3, I'd say 2.5 glasses. So thinking about the possible responses can help you determine what kind of variable that is. So if you said 2 glasses or whole numbers, you might tend to think this is not only quantitative, but you would think in this case, you would say discrete, but if you allowed for fractions or portions of a glass, you would say this is a continuous variable. Either of those are acceptable because I wasn't clear if it had to be whole number of glasses. I didn't restrict you to whole numbers. So either of these would be the correct answer. Okay, so sometimes there's room for difference of opinion. Okay. Ready for the next one? How dark is your hair color, your natural hair color? And the responses are listed here: black, brown, red, blonde, gray, white. I guess I could put, what do they call that, salt and pepper, gray, when it says gray mixed in with your natural hair color, which is my case. So what kind of variable is that? Okay, so for 3 categorical, so So I'm going to agree that it's categorical. However, is it nominal or ordinal? Are these responses related? So if I numbered them 1, 2, 3, 4, 5, 6, and I told you or if somebody said that they were gray-haired, number 5, and someone said that they were black-haired, number 1, who has darker hair? The variable here is the darkness of hair, not just hair color, the darkness. That implies that one would be darker than the other. Black is darker than brown. Brown is darker than red. I don't know if that's exactly true, but okay, let's say I thought that this was darker. Red is darker than blonde. Blonde is darker than gray. Gray is darker than white. They're related. The number, therefore, implies darkness. The smaller the number, the more dark. So, in fact, the answer here clearly was not as straightforward. It's ordinal. It's categorical and ordinal. So I caught you off guard. I meant to. Don't feel bad. It's set up. So I'm getting you to think about the relationship of those numbers. They're not just a category. In this case, in this variable, I'm interested in how dark. So some sort of ranking is taking place. So you thought you knew what you were doing, but hopefully you understand better now. Yeah, Gabrielle, I know that it's not exactly clear, but let's say I just determined that that's the ranking of darkness, okay? That's the unsaid in this problem. I mean, I could just leave it black, brown, blonde, and gray. I mean, well, actually, maybe blonde is, or I could just make it black, brown, and white. Then it's much more clear. But the point I'm trying to make is their relation. There's a relation between them. We can debate whether blonde is more than gray. The point is that one is more than the other is what we're looking for. That it's the interrelationship, the order that matters here. Ready for the next one? Okay, number 4, what did you get? Okay, so this number 4, like number 3, there's a relationship between these. And what are these? Are these quantitative options? I mean, there's numbers implied, but is it a quantitative variable? Well, no, because there's a range of possibilities in each category. These are categories. So how often do you usually exercise? Less than once, once or twice. Those are 2 possible values in one category. And more than twice, which is a lot of options inside of a category. So this is categorical. And do the categories relate? Yes. The first one, it implies less exercise. The third one is more exercise. So they are related. Order does matter. And this is categorical, ordinal. So if you get the sense, this is the kind of question you get asked in surveys. The analysts have to be aware, they in advance, that they are creating a survey that has to be, the results have to be quantified or assembled in a particular way. Cannot be treated, this variable cannot be treated like a quantitative variable. Any questions? So it looks like there's numbers, but the point is that it's not exactly measurable. If someone said, oh, once or twice, they're not giving you exactly a value that you can use to add or, to combine with other values from other responses. And combining those responses has some meaning, If you were to average those, you wouldn't know exactly how much people exercise, but you would have an idea if it was a low amount of exercise or a high amount of exercise. That's about it. Ready for the last one? What about number 5? Yes, Nivette, you got the hang of it now. So the next one is the same. It's the same situation. These are categories. They're not values. They're not quantitative. These are categories. And the categories are related. So it's categorical ordinal. So the best you can do is give them a number and put that in your Excel spreadsheet when people respond. And you have to be careful about the interpretation. Often data like this is taken and made into like a bar chart like this, right? And so, let's see. So results are taken and then a bar chart like this is done. category 1, 2, 3. Something like that to represent the data, but otherwise it's hard to say what the average income is, because how do you put those numbers together? You can't. Should I use for number 2 to come up with an average income? Should I code somebody as 25,000 or 50,000 or something in between? It's hard to say. It's not exactly clear. That's why I put a question mark. So, although many surveys you've answered are like this, the way that you analyze the results are going to be limited by the fact that these are just categorical variables. You can present some quantitative representation, if you do a Google form to collect information or data, or SurveyMonkey, that's the kind of output that it gives you. It gives you charts or pie charts to look at that, to summarize the data. But otherwise, it doesn't compute averages for you because it's not meaningful. Okay, so this course is going to, even though I've talked about the differences between data, we're going to focus mostly on quantitative data that is continuous. Okay, that's the focus of this course. I am going to talk about some introducing, we'll talk about it when we get to it, but basically our focus is quantitative continuous data analysis, okay? I shouldn't even say continuous necessarily. I should just say quantitative, because we do spend time on discrete data. But I'll just say quantitative data. The categorical stuff, like I said, for like SurveyMonkey and things, you just represent the data like this. I'm not going to teach you how to analyze it in a more sophisticated way. To do that kind of analysis, let's say if you want to make predictions or you want to find determinants of certain outcomes using categorical data, so like taking survey results and being able to say things like men are more likely to make more money than women, questions like that. Being a man or a woman would be a categorical variable, and you would be trying to relate it to a quantitative variable possibly, or another categorical variable if the data is like this. So that kind of analysis I'm not going to teach you, but we're going to focus on quantitative data. But after this course, you should be able to look into analysis like that and not have too much trouble if you learn this well. Okay? But the main point here is to understand that these are different types of data sets, and they require different statistics and different types of analytics. Okay, so that is my introduction to types of data. And that brings us to our review of the videos that you saw. I feel like my pages are crooked. It's in my imagination. Okay, so I had you watch those videos, and it begins with a discussion of experiments and what is an experiment, the good kinds of experiment, and then it goes into survey design and what are good surveys, what are good samples in general for either of them, experiments or surveys. In the video, they take time to talk about, in the topic, under the topic of experiments, they take time to mention to you the importance of control groups for experiments. Now, it's very important that you're able to isolate or control the subjects under investigation, so that either individuals or animal subjects or even objects like in a manufacturing process, the subjects of your experiment should be similar, so that when you're comparing outcomes, any differences are not attributable to characteristics of the subjects, but attributable to the treatment imposed. So maybe I'm jumping ahead too much when I say that, but that's really the nature of designing experiments, that you want to be able to claim that if an outcome is observed, that's because of the treatment imposed. So when an experiments are used to determine a causal relationship, causal effect of a treatment on a subject, or some sort of action on the subjects. Experiments are conducted to confirm beliefs, and often in the absence of experiment, we wouldn't even know what to expect. We have an idea, but it's really important to actually conduct the experiment, and that might turn up curiosities that were not in original theory on which the experiment was developed or set up. So we use experiments to test theory. And if we have evidence to refute status quo belief or theory, we can revise our theory. That's the scientific process. So we begin with a hypothesis, and we'll talk about this by the end too. This is where we're headed, to talk about making a statement of claim and then looking for evidence to refute the claim. And we make a hypothesis based on current or standard beliefs. Collect a sample and check if in the sample there's evidence as a result of the sample to refute our previous belief. That is the scientific method. And we'll be more detailed about how we do that as the course goes on. But we have to build various experiments discussed in the videos. Those are different from observational or exploratory studies, where the idea is just to sit back and watch and collect information to identify patterns or regularities in nature or in a manufacturing process or in a variety of settings, and you want to be able to see if there's any deviations from that pattern. So the difference between these two is essentially that you do nothing to the subjects that are being observed in exploratory studies, but in experiments you actually impose a treatment to see if there's an effect. You have to be careful in human trials because humans can actually be consciously aware that they're an experiment and might bias the results. There's lots of talk about bias, or we're going to talk about bias in the notes anyway. You don't want subjects enrolled in an experiment to know that they're in an experiment, or you don't want them to be able to change or impact the results of the experiments beyond what just happens because of a treatment imposed. So they explain in the video that if you enroll individuals in an experiment, let's say it's to test their health outcomes using a treatment. So right now there's a lot of buzz about a product known as ivermectin to treat in a preventative way the possibility of someone getting COVID, okay? So it could actually, there's some evidence that it can mitigate any kind of symptoms of COVID, and so make the experience less dangerous. And because of that, we want to study that in a safe experimental setting. Well, we don't want to just study people taking ivermectin. That wouldn't be meaningful, because maybe people who are proactive and people who are trying different things, proactive about their health, and maybe they have the money to spend or they have the time to research different kinds of treatment. Those kinds of people are different from people that other people who wouldn't be doing that. So you don't want to just look at people who are taking a treatment to see how they're doing. You want to be able to rule out characteristics that might bias your outcomes. In other words, you wouldn't want to just look at healthy people, right? You want to look at a broad range of people and determine in a broad range of people, how does this thing work? And you wouldn't want them to know that they're taking the treatment either. We run what's called double-blind randomized controlled trials, because if a person actually knows that they're part of an experiment and they know they're being observed, this is the important part, and that might influence their behavior. Maybe because they know they have to report in every week, somebody either calls them or a nurse stops by to give them a survey to see how they're doing. They respond to their general sense of well-being. Or we actually, find out if they visited a doctor or they've been hospitalized. Any of that information being collected, knowing that you are being observed, humans might change their behavior. So to control against that, we introduce a control group to our study. And we say, I'll use this space. I'll just use this visual. Now you saw in the video how they assign, people were assigned to treatment and control group, and we'll talk about that in more detail. What's really important to say right now is we want to record responses, right? How did people respond to the treatment? Now, people who are assigned to the control group don't actually get the treatment, but for all intents and purposes, they think they got the treatment. They get, so if it's something like, a study drug, then the individuals in the control group will get a similar looking pill in a similar looking jar, and they'll be told to take it in the same way as the people in the treatment group. So they won't know. The person also administering the treatment won't know that they're administering the treatment. So this is done usually if you're part of an RCT. A third party is involved. So maybe a pharmacy in a hospital is distributing the medications to patients that show up with a document or ID number. So they come to pick up their treatment, or if it's a vaccine trial, they go to get vaccinated, and their vials are marked in a certain way, but no one in the process, the individual receiving the treatment, or the nurse administering it, or a pharmacy representative delivering the medication, they don't know what they're giving. They don't know if they have an idea it might be a particular treatment, but they don't know if that's actually the substance in the vial or the jar, the capsule. This is managed by a third party that has been hired to randomize the treatment. So there's actually the treatment that's given or the control that is provided with a placebo treatment. This is a treatment that otherwise looks the same but doesn't have any medicinal properties in it. So why do we do this? I'm going to use this scale I'll call this improved health outcome. Or let's call it I'll say discomfort reduction. Or I'm trying to think, because there's two different ways to look at this. Let's just stick with pain reduction. So let's say people are receiving something for migraine. So these are volunteers who suffer migraine problems. Their doctors have referred them to this trial, and the individuals have been screened and then randomized into treatment and control group, and that has been done by a third party, so that when they show up to get their trial medicine, that person administering and them don't know what they have, but they just follow the instructions and take the drug. And it turns out that people not even getting a real treatment feel better. This is the level of pain reduction, or these are the number of people who have experienced pain reduction. Let's say it's 30% of participants. Say that they've experienced a reduction of pain. Oh, it's not working. Let me see what happened to the... Did we lose? Oh, we lost connection. Oh, 10 minutes ago. What I need to do when we lose connection is I need to start a new stream. So there might have been, yeah, it looks like I lost connection. So that means I'm going to lose the chat. I don't know, this is terrible. Yeah, all right, so what I have to do, I don't know, let's see if, yeah, my connection broke. Thank you for mentioning that. So let's see if I should start a part 2, but so we've lost the chat. When that happens, we lose the chat. Should I start another stream? Okay, let's start another stream. And I'll see you back here in a minute. Okay, so give me up to 5 minutes. Okay, so I'm going to put a continue stream. I'm going to call it new stream in the playlist. Wow, it's very rainy. You hear the thunder? Okay, I'll see you back here in a moment. So look for that new stream.